Welcome to the AI Think Tank podcast, the future of artificial intelligence, machine learning, and data science. I'm Dan Wilson, coming to you from Seattle, Washington. Today, our guest is Dr. Andrea Isoni. Dr. Isoni is the Director and Chief AI Officer at AI Technologies, a consultancy specializing in machine learning and data-related problems. He is the author of the book, Machine Learning for the Web, and has put a great deal of effort into the AI ISO standards. Today, we'll be discussing the current state of machine learning and some important points of focus for intelligent systems across many sectors. We hope you enjoy. Welcome to the show, Doctor. How are you doing today?
Thank you. Thank you for having me.
Yeah, it's a wonderful day to have you out, and just perfect timing with everything that's been going on this year, coming in on the heels of all the news from DeepSeek and just all the developments for what would be less needed compute to get more done. And it's an exciting time, and you work with many different sectors across different industries, and between vision and between, all like cybersecurity and, different types of digital transformation. There's so much to do right now. So let's talk about what you're doing right now and actually what your company is providing. It's really incredible what I've seen thus far.
So yeah, look, as you say, we were working in many different sectors, but look, at the moment we are most involved with it change over time. But as we speak, we are involved with a few company in finance that try to automate their own basically the operation system, the portfolio system to analyze for compliance regulation. They have a lot of compliance regulation, understand what's in their assets automatically. That's as much as I wanted to say. Obviously, we can talk more if you want, but that's the project we are now, and a few projects around compliance or AI solution related to, how would I say, defense or similar stuff.
Yeah.
Because whenever you implement an AI solution, it's not just because the UI Act, by the way, is being obviously is announced at least in EU and UK, but it's also because whenever you use AI solution, you need to somehow standardize the output to a certain standards, and or whenever hallucination is less of a problem today, that needs to be said, but still is something you need to write procedure around when thing goes wrong. Everything can go wrong at least once.
It's such a big deal.
Yeah.
It takes so much work to do this. I don't actually think many people realize this, even who are close to this, that on the other side of the wall, when you're developing, the back end prompting is everything. And if you were to change your model, it wouldn't work the same, and you would have to find different wording. And so it's an art and not a science. To some degree for you. It's very much a challenge. And I appreciate that standard that you're, working towards, and especially the ISO standard. Can you talk about that AI standard a little bit as well?
So first of all, for those ISO, what it means, International Standard Organization, every country has its own body.
That's right.
And what happened is most of your audience, I think, is familiar with 9001 for quality or 27001 for cybersecurity. That's the most well-known standards. Basically, if you need to comply either for quality or for cybersecurity standards, they were all the standards, by the way, for environment, etc. They have all the same, how would I say, framework and structure. I mean, there is a central policy, and then there are a procedure, there are risk register where things goes wrong, etc. This is a procedure framework that is kind of the same for each standard, including for a new standard that's been published last year. It's called ISO 42001, which is specifically for machine learning adoption. So whenever you have a model or an AI solution, you follow, if you want to have basically showing that you are doing the best as you can to ensure that the quality of the output is right. There is no also the how would I say, the output of the model is not harmful for the user or whatever. And you're doing not, this is needs to be stated, not that the model will not do bad stuff, but you're doing the max you can to avoid that happens. And
Right.
if happens, you're doing the max you can to minimize the damage,
That's
mitigate
right.
the solution. So it's
Yeah.
not that never happen. Nobody can do
Yeah.
that.
It's never
Right?
perfect. It's
Yeah.
just
No.
error correction. I mean, let's make a
Yeah.
real life parallel to this. So everybody remembers CDs and DVDs. Playing music on a CD. It uses the 9660 standard, ISO 9660, okay? And
Okay.
so that
Go.
standard allows for manufacturers to put music on CDs and then to play in all the players out there. But there are variations depending, one of them is, well, if it was DVDs, there's region codes for countries. If it's CDs, it has to do with the track width and the way that it writes it and certain other parameters, okay, can make it not as playable in older players than newer ones, even though it's a CD. And people would think, oh, it's just a CD, but it's how you do it. And when you talk about maintaining standards for ISO and AI, okay, the challenge is something that it isn't even at the model level. You have to work with your framework to prevent anything from coming out. And so that standard allows someone to really find it a lot of places where they can make it right. And so it's really worth pursuing. And I want to back you up on this. This is very important.
Absolutely. But let me
Yes.
clarify on that. I want to clarify
Yeah.
two things. First of all, is the ISO standard, even if you're certified there, it's related, but it's not necessarily a substitution for the law or the regulation need to comply first.
Right.
Second, my role in the ISO standard is voting for the standard itself, how it works. So there is the international centralized organization that basically decide different drafting of the different regulation possible. Yeah. These drafting are sent out to each country. Okay. Each country has its own committee, a committee member, which one I say. And then you vote for different wording of the standard. So what my role is, still is for related AI standards, to vote on the wording of the standard.
Okay.
Once the standard is applied, then you go to certify, etc. But my role within the UK and within the committee member, I'm voting for the wording of the standard. Just to clarify what my role is. No.
Yeah.
To be precise on that. Yeah. Okay. So
Gotcha.
basically, I voted for certain wording that obviously the wording needs to be. There are different, which is normal. There are different way. Well, there are different parties that want different things, right? Obviously, there are certain parties that want more strict regulation. The other party that, hey, if you do too strict, then it's hard to ask for certify, or we may lose too much money, or we cost too much to certify if you're too strict. Well, there are certain definitions that are ambiguous, etc., etc. So to come out with what you say before, Daniel, it's complex. Just to do the wording, it's complex.
Right. I see,
Just
and I know this.
And that's even more what you're saying.
Yeah, even in one language, even if you have one language and everyone even speaks the same dialect, this wording can get muddy because of the expectations and the definitions that people hold on one side of this, because you have different sectors working with it, you have different types of involvement, and a coder who's an ML ops developer who's working with a code is going to have a completely different view on this than someone who is trying to protect other different classes of society, in different cases, like educational access, okay, and for public schools, and that there's a different standard for that. We have to be extra careful, but everybody else can use different standards for different things, and that's fine. But when it comes
definition,
yes. So that wording is hard. So I have friends that do a lot of localization in the area. I have a friend in Italy who really helps translate many languages across volumes of big works, and it's a daunting task. And I can only imagine international policy and standards and the way you have to write is incredibly, a challenge. So I applaud your effort on that.
Yeah. There are things that I would say is I think it's a blessing they agreed on that. It's not my merit at all. I didn't vote for that. But for example, OECD, which is an international standard organization, if you look it up, he did a definition, I think, of artificial intelligence. Okay. I say it's a blessing because the same definitions has been adopted by EU AI Act and ISO standards. That is it's up again. It's I call it a blessing because simplify things, because at least certain definition across the board, and I think even IEEE adopted that. I don't remember, but I think it is. But anyway, all I'm saying is certain times to different bodies and organizations, if they use at least the same definition, that simplify the words, yeah?
Yes.
And it's just a little part of the whole process of that.
Right.
It's just one definition. Yeah.
It's critical. I mean, that helps unite your efforts too. It really does a lot of work for you in that sense. That is the blessing, is that now everyone is looking at the same thing in a way, and can accept that verbiage. So, and with all this, let's talk about like some of the projects that you are applying these approaches to, and where you're gaining benefit in this, because I know a lot of people who make decisions watch this, and a lot of developers watch this as well. And you and I do both, with what we do, and get to, really sit down and test, the technology properly. And I just want to say this, you have an amazing background. Your PhD in fluid dynamics, if I get that right. And your studies with data science and analysis through that is incredible. I have a huge amount of respect for what I call physical data science, when you're really doing the lab pipeline to the
I
actual
have to say, my
pipeline.
PhD was not in data science. It was
Right.
computational fluid dynamics.
Yes.
It was involving the data, but it was basically purely orientated to aeronautic study, vortex fluid, things like that. Now, what you learn there, yes, it's still adoptable as a framework, etc., to data science, etc. Kind of it is. But yes, my PhD, just to clarify, wasn't exactly in data science. Yeah.
Yeah.
But yes.
Yeah. But it is. But you were taking the results and you were turning it into the pipeline that you were able to do things with. I was just so impressed. Yeah, I looked into it, and I really like physics and devices, and also just the analysis of it. So I love that. And so you have a really great perspective on an experience with real, high-end practical ends, but also far-reaching, socially impacting ends of this as well. Because I looked through your case studies at your company and was very impressed at how many sectors you cover. Again, from behavioral models and managing that to the actual human interfaces, human machine communication. Your work in cyber security is really critical right now, actually, very important. And again, computer vision and other types of, edge technology that's out there for different devices, mobile and otherwise. Okay. And so this is everything that's going on, and even this covers agriculture too, and, farm analysis and different things like that. So there's a lot of great applications for the machine learning. And your book, you've been trend setting in some of this technology for a while. Your book, 8 years ago, you were on this. Your machine learning for the web was probably one of the first of its kind. And from what I can tell, yeah. And so, and a lot of these standards are changing right now as well, and we're getting new versions of things. The web needs to be more AI accessible for people, for their user agents, for their digital twins, for access. I think we all know in the developing end that if you try to reach out to a website, you're going to have to use a few tricks to get that information to your model to actually do something with it. And so there's a lot of behind the scenes things that companies like OpenAI, or, even Google, or, Perplexity, all these companies that supply these models, Claude, they have a back end framework that really manages the true intelligence of what's going on with these systems. It's not just some model, and it's not just some rules and some other prompting. It's very much a collaboration of applications that to get that out there.
To build the model, yes, absolutely. To build the model, it's not just training the model itself, it's to find the data. If you don't find the data, sometimes you use synthetic data. If you use website, you need to clarify which website, which categories. There's more curation or data cleaning before they're using in the model, and there's testing the model in different way, configuration, etc. In fact, one of the first thing is to say, when you read in the news that certain models are being trained with, and then there is a cost, whatever the cost is. Usually that is not the cost of, that's the cost of the final train or final run to train the model. Yeah, does not include all the cost of the pipeline that you need to do for training the data. Does not include all the trials or the final algorithm or the model, all the trial they did before is usually not included in that cost. That is the final run. Okay, when we set up everything and we are pretty sure that the algorithm we are going to use is right, the architecture of the model use is what we want, the data we are going to use is all clean, the last run, that's the amount. It's the amount considered just the last run.
Yeah. So that's the hidden cost of so much of that. That's something that I had to study a lot, which was if you get too far down the road and you did it wrong, you're going to have to start all over again, or you didn't quantize, you didn't, it's like distilling a model just like they did for DeepSeek. It took some very, very wise math to get that to work like it did and have such a good distillation after that process. So, and it's a mystery, I think, for most people out there, how a lot of this gets trained and built. But between building something from scratch and then catering something that already exists, that fine tuning or retraining, I mean, there are reasons to do this to make something more effective in a smaller size, to make it more specialized. Large language models are large, okay, and that they have a large corpus of data. And a smaller distilled version of the same model, it can communicate the same way, but it won't have as much knowledge to work with. But you can get it knowledge in the moment, and it depends, right? What are you seeing out there in your experience with that? Smaller models and their functionality or efficacy, versus the larger versions,
Okay. Even when we consider smaller model, we need to understand one thing. So where does small model come from? Usually from the large models.
Yes.
So what happens is you create, as you said, distillation, whatever, distillation, one technique. So you create a super large model. So what you do is there are different ways of it's not equivalent because they're probably exactly different things. So you take a large model that you shrink into a smaller model, and roughly has a bit, you lose a little bit of performance and precision, but that's now smaller. So, it's important to understand this because you cannot get to the small model directly.
That's
you
right.
first need a super large model, and only after you can create a smaller version of that.
There we go.
It's not a now everyone can do a small model directly. No, the first thing you need to do a large one and then distill into a small one.
Right.
Usually,
Yes.
Now, there are models to do a smaller ones. Yes, directly, okay? But that's not usually the case. What happens, and that's not the path for, what I'm trying to say is the path for best overall performance is not direct. Now, yes, you can do and train a model that is smaller from the scratch or from start. Yes, you can do. Will you get necessarily the best performance? No, not necessarily that. The best performance usually you do something very large and you distill. Usually, not all the time, but I would say it's 50-50. 50% come from directly, and the other 50% is just because you distill from a larger model. Today, looking at leaderboard, roughly speaking, okay? Roughly speaking. That's the first thing I want to say to the subject. In the future, I think we probably didn't mention that, but we publish in January a state-of-the-art report. We do every year. Everyone can download it. It's free anyway. So you can even see how good we've been in the years. We did since, we do since 2020.
Very thorough. Yes.
But we do since 2022, I believe. So you can see how good we were during the years, right? That's it. The reason why I'm saying that is because I still think through this year, the best top performance, I'm talking about LLM text, especially, no video, will come from the largest, the best, the GPU, etc., available, etc. That not to say that you could have, so it's complex.
Yes.
I need to introduce a few concepts here, if you'll allow me. So the first two concepts I need to introduce is what we call pre-training and post-training. So essentially, to train a model, you have two broad categories of training. The first one is a pre-training. Basically, from scratch, you take data, what we said before, right? Take data from whatever source it is, you curate, that architecture, whatever, mostly is transformers. There are new, by the way, there are new, as we say, last year, actually, not this year, and it was a right prediction. There are new architecture coming. There are I think
Mhm.
competitive at least.
Yeah, yeah.
To
State
the
state space
transformer.
models. Yeah, state space
They-
models have been around for a
exactly,
while, and
Mamba.
that's yes, Mamba. And so, and
Yes,
to
exactly.
everybody out there, if you don't know what Mamba is, it's like a transformer architecture, but not. It does the similar kind of thing from the outside, but really it gets to that result a
Yeah, it's
very
not a
different way,
transformer.
and it
It's
doesn't.
another
Mhm.
architecture. Yes, exactly
Right, and
right.
it's not good for everything. It has its special uses
Yeah,
for sure, from what I've
yeah,
found it personally.
yeah,
But so
exactly,
this is
exactly.
exciting. Yes. So go on with
It's
that.
exciting because
Uh-huh.
we are getting over one architecture from
Yeah.
a purely scientific point of view. Is very exciting. There are
Mhm.
pros and cons in using different architecture. To the
Right.
point that I think we wrote in the report that now what I believe last year, one of the most, if not the most influential paper of the year was called Mixture of Expert. Yeah.
Yes, yes, that's
From
right.
expert.
Uh-huh.
What I believe one of the most, if not the most, why is the most influential?
Hmm.
Because if you look at the leaderboard of today, as in today as we're recording,
Yes.
most, including DeepSeek, all the top performance LLM use mixture or expert algorithm or approach. All
Uh-huh.
that.
Uh-huh.
So that is an indication how influent was that paper. Yeah, they all use
Mhm.
the same methodology.
That's right.
Not only that, obviously,
Hmm.
but it's one of the main key of the performance is still mixture.
Yeah, that's right. That's their
There are reasons
KPI
for
is.
that is
Hmm.
because you can do with basically with the same number of parameter different thing at different times.
Hmm.
You activate just a part of the neuron, and
That's right.
therefore a smaller model actually acts as a bigger model, roughly speaking. There is a law or exponential law, I think we multiply by 4, depending on the situation. So
Hmm.
50 billion parameter actually become times 4, okay, or times 2, depends on the situation.
Yes.
But that said, the reason why I'm saying that is because the next evolution, all I've seen in the paper this year, okay, so this year we have seen that, okay, transformer are still on the top. Yeah, transformer as an
Hmm.
architecture, still the top performer. However, very competitive, we have Mamba. Yeah,
Yeah.
space.
Yeah, that's right.
And at the same time, there are already emerging some papers, I think for Indeed, they are trying to hybridize methodologies, not the mixed architecture. So what I really think, I think I wrote in the report, it's
Hmm.
very possible that from mixture or aspect, next year, the best next year, I think from now to 2060, there will be multiple attempts to mixture architectures somehow,
Yes.
somewhere. I don't know
Hmm.
exactly how, obviously, but
I'm
it's
excited
a
for this. This is
they,
what I'm really interested in right here,
there will be someone,
personally. Yeah.
they already, I think they're trying something like that. And the
Uh-huh.
moment you do that, probably that will be the best model because you're not just
Uh-huh.
combining one architecture, you're kind of combining two somehow, somewhere.
Yeah.
The
Yeah.
NVIDIA paper sort of get there, but it no
Hmm.
wasn't architecture. It
Hmm.
was a little bit more complex than that. So I
Right.
still think it's that. So the best performance will still
Hmm.
come for the best money,
Hmm.
the largest model available, kind of a mixture architecture. In any case, the performance will be, I think, not more than 50% better than the most the smaller models, like
Yeah.
50 billion or below. Yeah.
Uh-huh. Yeah. Yeah.
That's what I think we wrote in the report. I hope I citing
Uh-huh.
correctly. That's not to say that there will be a place. This is just for pre-training, by the way. Yeah, I'm
Hmm.
talking a purely pre-training model.
That's
Now,
right.
there is a lot of discussion of post-training. What I mean by post-training, and that's something was apparent during the years. I mean, the influence of reinforcement learning by human feedback or DPO, direct process optimization. But anyway, there are once you create this large model, sometimes you want to refine the result. And by definition, when you refine the result, usually you refine a certain topic.
Yeah.
You
That's
can refine it on everything. Yes, you
no.
can, and they do it. But
Yeah.
usually the best result is you, instead of doing everything for all the metrics, I mean,
Mhm.
reasoning and math and poet literature or
Right.
understanding, you may do one post-training, so after the model is created, to one specific subject.
Yeah.
Now,
okay.
My indication is during this year, you will see specialized model, which means a large pre-trained model, then post-training for getting best performance out in one metric, usually a hard one.
Yes.
Like
That's
math.
right.
Let's say
Yeah,
math.
that's so tough. Yes, exactly.
Exactly. But you
Yeah.
are gonna post-train specifically on one and get the best leaderboard performance, not across, not on average all the metrics, but specifically for one.
Yeah, vertically.
Vertically, yeah. And you do that for post-training with reinforcement learning from human feed or similar method like DPO or something. And there are two ways you can do that.
Okay.
Or I think I expect to do that. Either is a company that has a lot of specialized data or created the specialized data set. Somehow he created that. It will be prepared. Therefore, if he created that, very likely will be proprietary. Yeah. Yes. Or the other way, which is a bit quote esoteric, is well, we need to introduce a whole series of things. It's about the blockchain now. Now, it's a very complex. If it wasn't complex enough, there is another complexity on what is happening on the blockchain. So there are different projects that are kind of converging with AI in the blockchain of various source, of various type. One of these type, not all the blockchain AI, but just one of the type is about creating a platform in which people can collaborate somehow to train their own models. Okay? Yeah. So, and get the better performance because they collaborate in their own model. It could be for the data sharing. It could be literally because they put their compute somehow, somewhere. Now, there are a lot of limitations on that because one of the main problems is actually the connection and the communication being among the GPUs that actually is the most efficient way.
The shared memory. Shared memory.
Yeah, shared memory, exactly. That's the key to have increase the performance. So there are limitations on doing that. However, if there are a lot of people sharing, you may get something out of it, even if you have very low bandwidth across the connection. Yeah. You just basically overcome the low bandwidth connection with a large number.
Yeah, brute force basically is basically brute that's force. What gets through it. Yeah.
So I think the fine tuning, the post training fine tuning one metrics top performance, either we come up with a proprietary data company that just do that because they have the data, they have their own cluster of GPU, of a lot of people on a blockchain. They figure out one metric, they all together and they do that. Something like that. I know it sounds esoteric.
Yeah, it's amazing though. That is amazing.
I know it's esoteric. I can give few names so you can research yourself. It's in the report level. BitTensor is one of them. They're doing something around this line. And there is another one of Macrocosmos, I think it's called, something like that. It's in the report anyway. And there are others. But this is the one that I believe the most famous one. The other one is I think, but it's less specialized in these.
That's it. Yeah, decentralized. So Macrocosmos is an open source, intelligent, incentivized. It's incentivized and designing incentivized mechanisms, enabling fast and powerful decentralized machine learning. So it's like a general accessible compute chain, like what you're saying.
I want to simplify a little bit.
Yes, please.
So we and I, Daniel, I think we are old enough to remember Encarta versus Wikipedia, right?
Oh, yeah.
Yeah, exactly, right? So one is proprietary, obviously, I think it was Microsoft, right? I think it was Microsoft. Maybe wrong. Encarta, was it Microsoft? Yeah. I think it's
not quite sure anymore. Yeah.
Anyway, it doesn't matter really. But for those that don't understand that, okay, before the internet, if you need information, you need an encyclopedia, basically, paper one, physical one. The natural idea when the internet came from is to have an online encyclopedia, still paid, still proprietary and paid. One of the most famous one was Encarta. Yeah, which I
Yes,
think it
that's
was
right.
Microsoft, but
Hmm.
I could be wrong on
The
that.
first one was by Wes Kussmaul, and I actually had him on the show
Uh,
last year, and he actually invented
ah,
the first internet encyclopedia, and
oh,
then eventually other ones came after that. But that was his first
yeah.
social media platform. It was the
Was
Wes
it
Kussmaul
private?
Internet. Yeah, it was the Wes Kussmaul Internet Encyclopedia, and it was over Delphi, which he produced
Okay,
Delphi. Yeah, so but I've seen
okay,
the origins of this since the 80s. And because of my
yeah.
involvement with computer systems and even back to BASIC in 1984, that's when I started with it, and that's when I started seeing all of this as a kid, even and in my
Yeah.
involvement. So it's so important to like the way that's grown and what you're talking about right here. So keep going.
So
Yes, exactly.
yeah, so
Uh-huh.
just wanted to clarify. So there was a private company with private information. They built an encyclopedia, the best you can
Mhm.
curate, etc. But it was still private. On the other side, completely different. There was an no-profit organization called Wikipedia with a lot of people for free volunteering. They were
Mhm.
putting together stuff for free in their own leisure time.
Yeah.
There was the battle of the time. Obviously, Wikipedia won. We know that. Well,
Mhm.
now we cannot. I think, but I am certain it's gonna win this time, and I explain why. At least today, I am certain it's gonna win. But I think, if not this year, next year we could see kind of the same. The next year we can see kind of the same battle. When I'm in models, yeah. What I mean by that is there are companies that have a lot of proprietary data. They are on their own expertise, etc. They try to produce their own models. On
Mhm.
the contrary, there will be, I think, blockchain enabled, a platform and a network, people, a lot of people that for free or with some incentive, I think there needs to be some incentive because
Yes.
running energy, etc. we go, but blockchain will allow that.
Yeah.
But a lot with some incentive that we could somehow collectively together to produce
Mhm.
the best model. It's
Yes.
the repetition of that.
Mhm.
If I can
Yeah.
add on that, there is
Yes.
an irony on all this.
Mhm.
The irony is, if you know all, especially we go back, is like GPT-3, like, and not
uh,
even 3.5 is the one famous for November when ChatGPT started, GPT
yeah.
3.5. But
Mhm.
GPT-3 or before, the bulk of data was Wikipedia.
Yeah. Yeah, that's right.
So the one
Uh-huh.
that won against Encarta.
Yeah.
So everything is based on already one battle, and the same kind of
Mhm.
battle can somehow repeat again. Now,
Mhm.
the reason why I'm not certain that still the blockchain can win is because I'm not certain they can be solved the intercommunication thing fast enough.
Oh, yes.
So basically,
Yes. In
I'm not
parallel.
certain in parallel they can
Yeah.
do it. Now, we need a lot of people to do it. That's okay.
Yeah.
Somehow could
There's a
happen. I
lot.
could
Yeah.
see.
Uh-huh.
They could, like Wikipedia happened, that people getting
Hmm.
there for free and doing that. No
Yeah.
problem. I could see that. What I'm
Hmm.
not clear about is uh few GPU, well, not few, a lot of GPU, even less power for
Hmm.
the best in the market, etc., can communicate fast enough across each other to build together.
Yes.
That's not
Oh,
clear to
yeah.
me.
Uh-huh. So you're ahead. I love how ahead of the curve you've been over the years. Okay. And just in researching what you've done and how you've done it, like here, this is so important. And I want to make 2 points for everybody here. One is that if you read the news in the last week or two, there are groups of people that are taking their blockchain for Bitcoin mining and turning it into compute farms, just like that. It's the exact same adaptive
Okay.
pivot. They're pivoting to something that really is in demand, and it's the same cards. It's still an NVIDIA graphic, processor. They're really geared at doing math and floating point operations, and are optimized for it. And so this is important. Also, I would like to clarify something for everybody. When you say post training, or you come down from the large model and you want to what do you call it? Really specialize in one vertical performance metric.
Not
Okay.
necessarily, but that's
Yeah.
the
And
natural
yeah, as an
way. Yeah.
example, so here I want to bring this up because I am such a big coder and I test so many of the coding models. Okay. Code Llama, Gemma, they had a code Gemma, DeepSeek Coder, Quinn Coder. Um, if you take any one of those models, that would be a good example, perhaps, of what you're talking about,
So
specializing the one metric. So we're going to give it post training to be good at coding and have that. reasoning and corpus of knowledge in there, or we're going to do one that's not for that. It's for more language translation. And it's so like
Yeah.
ASA. You remember the model last year? ASA came out. It's on Llama, and
Okay.
it
All right.
has maybe 100 something languages into it. So it uses its focus for
Okay.
actual translation and not
Okay.
math and
Sure.
not
Fine.
programming, right? But there's still a lot of math to language, in that sense, a lot to work out. So and that was great. I tested that quite a bit. A lot of people did. And then also what you're saying with taking something and make it more optimized for certain applications, that's what a lot of people are doing with agents. And that's what
Mm.
I've been doing with agents that I've built from scratch too, where I'll take a smaller model just to check the code and error
Sure.
correct. And then the larger model is the one composing it. But they work together in conjunction to create working code that runs, and they debug it, and then they install software they
Yeah.
need to fix that even. And then until I've got a working product. All the
Yeah.
while I've been doing dishes. And I built this thing to just work. But I use these
So,
models myself without much specialization, and I'm able
yeah.
to get results that work for
But you're
me.
still a coder,
Yeah.
right? You're still a
Yes, I
coder.
still
You
code.
understand exactly
Yep.
your technicality level is very good, etc. So just
hmm
I think you're going to talk about agentic AI, or
Yeah,
right?
because that's what that's the thing though, is those smaller special models. Sometimes what you're saying, I've been seeing companies use them in little places to do one
Sure.
thing, just
Mhm.
summarizing or just
Yeah.
handling function calling, actually, in some
Mhm.
cases for certain things. But go on, because you have such a great amount of wisdom in this, and
No,
I'm
no, no.
definitely learning
If
with
you
this
want to
too.
do, when they refer
Yeah.
to agentic, it usually
Uh-huh.
is a process. So basically, you give an agent a one prompt, and
hmm
they themselves split in subtasks of
Yeah.
a process, and they do all the
hmm
tasks, right? Like you
Right.
go to the find me all the information. Well, go and buy, I don't know, go and buy size S, a t-shirt, red
hmm
color, brand, whatever. And then
hmm
they go online, and then they do all that. So they split into the stuff. Okay, go to the internet, go to the
hmm
browser, open Amazon and different content,
hmm
and they do all of that by themselves. So
That's right.
this would be the concept of the agent. Now, we are a bit early. Well, two ways to say that. So for companies, we are very far, because
hmm
company needs the regulation. There are a lot of caveats. There are if
Yes.
statements. You need, before deploying something like that, you really
hmm
need to know all the if, and if it goes wrong, what happens. So you need a lot of testing and quality. So no, I would be very, very surprised if you have because if you read in the news, it looks like the agentic era is coming now.
Yeah, like that, but it's not.
No, no,
It's
no. It's
not.
too complex. It's
It
too
is.
complex for
Yeah. Uh-huh.
industries. We are far, because there
Uh-huh.
are a lot of infrastructure that needs to be
Yes.
built just to allow that. Even
hmm
assuming that the technology of today will allow that, which I think is still a little bit lacking. But even
Right.
assuming that it will be ready today at
hmm
perfect, which is not. But even
hmm
assuming that, the infrastructure is not there anyway, because you need, again,
hmm
we were talking about ISO certification just being approved
That's
last
right.
year.
Just
UAI
now.
Act is being approved in August,
Uh-huh.
and all. Texas just approved a law, I think, last month.
hmm
We are not ready at all
That's right. That's
to
right.
scale
Yeah.
that in
Uh-huh.
industry. Just I will be very surprised.
Yeah.
Anyway, now it's a
hmm
different thing if you talk about coder like you, or they have a bit of entrepreneurial spirit,
hmm
etc. They want to do their own agentic situation, and they want to do it. For example, very famous last year, there was I think it was Sakana AI, it's a lab. They build everything to do their own agentic research. So
Uh-huh.
basically, they build up an AI agent that is doing research for them. So basically, they say, look, go and find out new research. I don't know, I don't remember
hmm
exactly, but doesn't matter. The
hmm
core concept is this bot is gonna write a code, it's gonna test the code, it's gonna write the paper, text that the paper is right,
hmm
refine the paper, and loop and loop and loop until he
hmm
basically build all the research by his own, and
Yeah.
build that. Okay.
Yes.
This is but again, this has been done by not someone that prompted, someone that know about research,
Mm-hmm.
is a coder themselves. They have a little bit of entrepreneurial spirit,
Right.
etc., etc., etc. It's not
Uh-huh.
something that a normal guy with no knowledge about technicality at this moment. In the future, it will be maybe, but
Yeah.
this year
Not
it's
now.
too clunky, it's too complex. There are too many
Uh-huh.
variables to set up. You need to know a
Yeah.
little bit of coding to
Yes.
do all of
Yes.
that.
Yeah.
Not
Yes.
today,
Uh-huh. To your
or
point,
just to have prompts.
there's a company called Devon. I think I've
Yeah,
got that right. And
sure.
it's like they charge a lot for something that it's still evolving in functionality. It's not a solid system. It's a very good effort they are making, but at the same
Oh,
time, you're paying $500 a month for what's really
oh.
like a junior mid-level coder that does stuff and tries to learn in the background. And I don't want to speak to it too much because they've done such a wonderful job with what they have. But
It's
what you're
efficiency,
doing,
right?
yeah, yes,
But
the efficiency of it. Yes,
but it's not a
yes.
process. What you're going to
Uh-huh.
have the desk, it's not. So when you pay this company or whatever, they speed up
Mhm.
your own coding, but they don't do all the process, right?
Oh no, no.
Exactly. So
There's
that's
so many
okay,
moving
and that's
parts.
okay.
Yeah,
But
that's fine.
when you
Yeah.
talk about agentic, there's no
Uh-huh.
agentic means they do all the process.
Mm-hmm.
An agent is someone that basically replaces all the process, not just writing the code, but checking the
Yeah.
code,
Yep.
check the scalability.
Verify. Mm-hmm.
Yeah, but obviously the final verification should be always on the human, please don't have it. But all the process around has been, handled by the agent. Yeah, that's what they
Yes.
refer to. It's too far. Unless, again, you are a specialized coder,
Mm-hmm.
etc. Then you can do your own agents. It's
Yeah.
possible today, but you need,
Mm-hmm.
again, a bit of SSD, so not definitely
Mm-hmm.
something that can spread out in the market and
Yes.
mass.
It's
No.
someone came up with the idea. It was like tier one agency, tier two. There are tiers to the levels in which, something has interactions. Like I built something that does one thing as an agent, and it can do a lot of things automated, but it could do more. And the things it doesn't do are it doesn't go to GitHub and look at other code yet, right? It doesn't do anything outside of my private systems.
And that
But
would be one step
yes,
all
that
of
would
the
be one
process.
step, right? But if something could always be in agent mode and waiting for whatever should happen, looking and doing something with that one prompt or the one direction, um, it's going to come out to one use in that. It's going to do one in particular thing very, well. Whether it can do several things or not, there is a finality to what we're getting at. There is a definite delivery of what it would do
Again, you need
for
experience in
you.
coding, etc., to
Yeah.
build all the funnel and
Yes,
to do it right.
exactly.
And the
Hmm.
agent will do that. Someone that has no experience on that, it will do all the funnel of that. It's too early for
It
that.
is. Yes. Hmm.
But there is another, again, but again, we are talking about technical people. Again, is the blockchain.
Yes.
Well,
Yes.
there are agents now, which is incredible, especially on social media. I don't remember the name. I think it's AIXBT. I think it's called like that.
Oh
So there's
yeah.
a channel on X or
Uh-huh.
Twitter. I think it's called AIXBT. This is a true agent, but again, it's developed by a company, not someone that just put it
Hmm.
a prompt. So this agent, what it does is as the list all the influencer on crypto and crypto investment, etc.
Hmm.
It screen that every second and then output and what based on all the things in real time it can read and digest it
Hmm.
out on his own channel information about summarizing all the other in real time.
Yes. Yes.
And this
Exactly.
channel, this obviously is a agent thing, but it's done
Uh-huh.
by expert. It's not done like that.
Right.
Second, there is a huge value on that, but it's still in. You see, there is a conversion with the blockchain because these
Hmm.
guys are. I think they are using virtuals to basically make their incentives for the model to happen,
Hmm.
and yes. So again, agentic AI is a reality. Yes, but just for the expert, unless you want to, unless obviously this
Hmm.
channel, this bot,
Yeah.
it's basically, I think it has 300,000 followers
Right.
because
Right. It must be doing a
this.
good job, you know?
Oh, I'm sure, absolutely it is,
Yeah.
but it's an
Uh-huh.
agent. There's no one. Well, there
Yeah.
is a company behind it, but there is no
Yes.
person. But again,
Hmm.
people are interacting with the agent as in they're reading what it does because it does
Hmm.
an analysis way better than that because it's real time, can analyze a lot more than blah blah blah. But again, it's as a final user in this case, yes, you can use it, but thinking that a person with no coding especially no nothing can deploy all of that 2 days, no.
No. It's not. Yeah, exactly. This is,
No, yeah.
it's
No, yeah.
almost like when you talk about that agent that, reports and keeps up with the trends in the crypto, world. It's almost like back in the day, a daemon. So you would run a daemon on your computer, it would just
Yes,
always be listening and waiting, listening and
correct.
waiting. And that's like the first agent
Yes,
system, if
yes,
you think
yes,
about it, way back in the
yes,
80s,
yes,
90s,
yes,
like,
absolutely. A daemon.
yeah.
Yes, exactly
So
right.
uh-huh. And so it's just waiting and listening. But a lot of the stuff that I'm working with at Quai, which is a nonprofit for democratizing AI, there's like 750 members, but we're working on that digital twin agent aspect where a user would have their credentials loaded into it and it could do things for them like, oh, book me a reservation at this restaurant. And I know people that do this already with things like this. And it goes on and it calls and it uses voice and it's a copy of the person's voice and it books the reservation. And then it reports back and sends them an email or a text to their phone. Hey, you're booked
Mhm.
for 6 p.m. dinner
Yeah.
for two at such and such restaurant. And that is a wonderful example. And
Sure.
you had made one where it was able to have credentials to go buy a shirt, for example, on
Yeah.
Amazon, or I need to pick up something,
This is an
what
agent.
have
Yes.
you. Yeah, there's a
But
wide array of things we automate, but
but
there's some things we're not used to because we don't have those systems yet, like you're saying, okay, with the completeness. Okay, go ahead.
correct. It's not
Yes.
done
Hmm.
by, I'm sure, even the example of the travel agency you said, is not
Uh-huh.
done. The one they developed the agent, as you say, has not done by non-coder yet,
Hmm.
right? I'm sure there are some coder involved in creation of this travel agent that you're saying, right? Booking the
Yes.
hotel, etc.
Uh-huh.
I think you correct me,
Yeah,
but I think
that's right. Yeah, they built it from scratch and they have their own platform that they did that with at home.
exactly. So it's
Yeah.
not someone that, right there, I want a travel agent that does this, please build me the bot. It doesn't
Hmm.
work that way today.
Right. Yeah. So, I mean, there's a lot of room for growth in how we
Sure.
manage these types of things. But for you with your company, I'm so, just taken back by how much you're able to test, I suppose, with your knowledge on this. So keep going with, and also include what you are doing behind the scenes with this yourself, or what you think
Mhm.
you're going to do next. What is on the plate for you, in your
Look,
company? Hmm.
yeah. So obviously we are a consultancy. So our job is basically stay on the top of any leading AI technologies that
Hmm.
are available, testing. And therefore, when we have a new clients that want to do a project, basically the bulk of our rating is actually project, which means they hire us to build a solution for them. As you say, in very industry, if you want, we can give you an example. Actually, all the time, the intellectual property goes with the client. Yeah.
Hmm.
Sometimes it's what we call more mature technologies. Yeah, like easy today, kind of customer service chatbot, something like that. Just to clarify that this is doable within the limitations, etc. Is quote mature technology. Yeah, we
Yeah.
can build that, etc. But sometimes are more innovative and an intellectual property value in like drone technology for automating
Hmm.
control the drone in certain way or certain stuff. Just
Yeah.
as an example,
Hmm.
agentic system for automatic reporting in certain type of the market.
Yeah.
But things like that, that may actually there is an intellectual property value on top of the return of investment given by the efficiency bring. Yeah. So
Mm-hmm.
we do
Yeah.
these two type of project. One is purely based on we understand very well the technology, implement, and the return
Mhm.
of investment is basically on the efficiency the new solution will provide to the client, and or mixture of new efficiency and intellectual property given a new solution we will bring to that.
Mhm.
This is
Wow.
the
Cool.
the,
Yeah.
the, the, the two kind of solution. Therefore, exactly this is why you see me
Uh-huh.
it also us, not we don't hide that to develop the state of AI report every
Uh-huh.
year, right? Because that's also when you write it, it's also clarifying to yourself where you are at, where you're thinking
Uh-huh.
that. And
That's
also so it's a feedback loop even for us, right? To
uh-huh.
know exactly what's going to happen, and we could help our client the
That
best
was
possible way.
I read a lot of reports and that was a good one. I mean, like really
Thank you.
just that really felt like he captured the zeitgeist and the spirit of what's going on right now and kept it very reasonable and
Mhm.
very careful because look, we have to make prudent decisions We always had to, we always should anyway, but now more than ever, would something could change price very quick based on a miscalculation and compute. For example, the people out there who aren't aware, you can use a token calculator that will take a paragraph of text that you have, paste it in, and it will tell you how many tokens it will take to process it. And if you only have a certain amount of tokens that you can use on a platform, or you're trying to keep up with your API costs, then this is how you calculate costs and project that and understand, hey, when you're talking to a client, it's going to cost this much to do it. But like you said, if you're not including all the other parts of the post testing and verification, you're not getting the whole picture. It's three
No.
times as much as that first number, maybe more,
Yep.
depending. And if it just works the first time, and you
Correct.
don't have to redo anything, right? So,
Yep.
I mean, it's a careful process. It's not guesswork, but there is a certain amount of trial and error involved. Am I
True.
correct? I mean, you,
Absolutely, absolutely.
yes, yes.
We have been recently involved, for example, we have recently been involved with an organization that we are developing right now. We are in discussion and started the first test on grade marking, yeah, for certain exam, yeah. So the
Okay.
candidate needs to do a certain written essay, and you have marking system and that. Now, you could argue that using ChatGPT or AI, the latest model will do a good job, and they do. Yeah. So basically, no need for us kind of thing. But the problem is when you want to do that at scale, yeah, you
Mhm.
need to test a lot of things
Oh
because
man,
you
yeah.
cannot afford the mistake.
No, you can't. You have to automate those
It's a
tests too.
company. I
Oh
mean, they are
yes.
liable to
Yeah,
do
look at the air.
certain
Yeah, look
things.
at the.
It's not.
It's like that airline company that had a chat bot get them in
Yeah.
trouble and lose a bunch of money because it
e- e-
made some
Exactly. If you
guarantee.
want that,
Yeah, you
exactly. So
cannot.
you need
Uh-huh.
to do that liable. And so therefore
Mhm.
there is a pre-processing kind of thing before even touching the actual model that do the grading, the pre-process the data in a certain standardized form, blah, 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 from all the users, etc., blah, blah, blah. Then there is
Mhm.
a model itself, which needs to be trained in certain way, etc. If
Yes.
you have a suspicion that the grading is not exactly for different metrics as is supposed to be for other different metrics. So
Mhm.
basically you do a model with other independent model that does that. If they since they are independent and collide as in the two, I say two, but probably gonna do three, but we are testing for two now. Do independent model, you do the gradient, the kind of the gradient agreed for
Okay.
different metrics. Okay, it goes on. But if they don't agree, you need certain pipeline or tests to understand why they didn't agree because of that, etc., etc. And all of that, this is important, is all these pipeline as in coding, you will say log if your audience is technical enough or does any
Hmm.
kind of coding, they will
Right.
understand what I mean by log. It means
Yeah.
that at every step of code, any code, by the way, not artificial intelligence, you
Hmm.
could put some output of the
Yes.
intermediary
Report.
process of step.
Yes.
Yeah,
Yeah, you can get
exactly.
your live real time like
And
metrics right
that's
on the
and
side.
that's in a
Yes. Uh-huh.
system is
Hmm.
fundamental. What I mean by that, imagine GPT, etc. Right?
Yeah.
Let's use this the same example. So they want to give you back an answer for the grade. Okay, they give you back the answer of the grade. Fine. If it's wrong, okay, why it's wrong? You don't know. You couldn't know
Uh-huh.
possibly because there is no logs.
Yeah,
There
there
is
is.
no paper.
It's a black box. This is what we
It's a
talk
black
about out
box.
there. Is the black box of AI. Yes, thank you. And there's no
So
explainability in that without any kind of like tap into
no,
the
the
report of that.
only
Yeah.
way to have an explainability to understand at which point of the step is it because the data and it messed up because this essay is different from the
Mm-hmm.
other essay? Could
Yeah.
be. And which
What's its
one is it?
chain?
Is
Yeah,
it
the
the
chain of
model and
reasoning.
the model,
Mhm.
or which one of the two? Now I say two, they are colliding. Is one that is going wrong? Is both they are
Mhm.
going wrong? Which one? For what? I mean, but if you don't, as it say, you split the box into a process, and
Mhm.
you will not identify which part is committing the crucial mistake, the propagate
Yes.
into the that.
Uh-huh.
It's just a black, but it's brown. All right, I'll close it.
Mhm.
I don't know.
Yeah, you can. Yeah, when you are using, let's say, and this is for the audience out there, if you're using DeepSeek, and look, I don't use DeepSeek on their platform or server. You can't even get it anymore, really, because they never could support the processing. Okay, even
Yeah.
if you paid for
So
the API, there are plenty of American companies that host the DeepSeek model, 70B and 681
so
billion parameters, and
yeah.
32, all that through Azure, Amazon Web Services, Google Cloud. Okay, and I do it at home on my own hardware. Okay. But here's the thing. When you talk to DeepSeek, it actually shows you its chain of thought. It's called COT, chain of thought. Okay. And it goes like 2 or 3 sentences at a time, little paragraphs. And it says, here's why I'm reasoning this out. And you can see why it's going down that logical trail. And that's inside of these brackets that say think, and then it is terminated, has a think tag. Well, you can send that out and actually make a log of reasoning on a separate log, which is what I do
Yeah.
through all those conversations that I have with it. And I can
Yeah.
tell when it made a wrong turn and why, even though I can't tap into the true black box of where that neural network
Correct.
is doing the reasoning, the output will, that output in chain of thought is so powerful to show you that it is the closest thing I have found to getting to that real-time sort of black box. Not really,
Exactly. This is
but
it's not,
something
I completely,
close.
it's not really,
Yeah,
but at
not
least
really.
make the
Uh-huh.
audience understand what you need
Yes.
to
Mm-hmm.
debug something.
Here we
Not
go.
really, exactly as you say, but at
Mm-hmm.
least if for a non-coder
Mm-hmm.
audience, they understand why you need that. Because without that, you don't know what to verify, in
Yes.
which direction,
Uh-huh.
in which direction you need to go. This is the closest thing you could say. Thank you. Yes, exactly right.
Yes. And
For
this
now,
is the
coding audiences make sense.
they're
Yeah.
guessing machines. Look, large language models, transformer architecture, the way it works is probability, and I'm speaking to the audience here in that it's like
Sure.
Bayesian inference, you have K nearest neighbors, you have different word associations. I mean, we are almost very predictive in our minds about certain things as well as humans, but we are accountable. We know what we were thinking, but the black box of the AI is it's kind of like the black box of an airplane. Okay. It has all the flight data and everything, and it's all, encrypted into this one big, thing. But with AI, we're not even trying to hide it. You just can't see or detect how the deep learning is going. And it is making those determinations based on internal inference with associations of proximity and other things. So without being too technical, I mean, it's a guessing machine. And to watch how it guesses, you need a way to log it. And we really don't have the exact direct path to that right now, mathematically.
No.
And that's definitely a next step, is cracking the black box and making it explainable AI all the way down the line.
Oh, yeah, I
Yeah.
don't
Mhm.
think we will never get, since the number of parameters is to the billion or something, and we
Yeah.
never know
Yeah.
exactly which one is activated. Even if you know
Mhm.
which one is activated, it's very difficult to understand why, etc. I don't think explainable AI in the true sense of understanding why what exactly
Mhm.
each neuron activation means in the
Yeah.
constant online output. I don't think we will never do that because
Yeah,
I don't
that's
think
right.
it's
Uh-huh.
possible. At least that's my opinion.
Yeah.
But no, I know there are many attempts to do that from a
Mhm.
neuron activation
Yeah,
perspective. But
you'd be
I
trying to
don't think
force
we're
it.
gonna get there.
Yeah, you can't because we'd be trying to mathematically force a deduction that you don't have all the parts to deduce to get that. And so
On
that's,
top of that, there is no
yeah.
standardization.
Yes,
I
thank
explain what.
yes.
I don't know if the audience. So I simplify. So forget. Well,
Hmm.
not forget, but putting
Yeah.
aside the large language model, talk about where everything is kind of coming from. It's called word to
Hmm.
back. So
Right.
basically, word to back is the one of the first models. Not large, but certainly is a model. They
Hmm.
take all the take a large amount of text. Let's say Wikipedia, because it's
Hmm.
Wikipedia one of the largest that used to any of these models.
Yes.
Um, and all it does is calculating the probability that each word is close to another word. Yeah.
That's right.
And at the end of the day, what you're going to have is each word in the vocabulary will have a certain probability to come after a certain other words or
Right.
etc. That somehow will constitute is relative. That's the key word, relative
Hmm.
meaning to the other word.
Yes.
So
Mhm.
imagine a 3D graph and network.
Mhm.
So each word is closest to the other based on how the probability is going to go before or the other, or close to the other in a sentence or things like that,
Mhm.
right? And
Yes.
therefore, these create the meaning, the relative meaning. Now, here's the problem. This relative meaning, although it's the same, yeah,
Hmm.
it could be generated by different activation on neuron if the model has been has been how do you say initiated in a different way
Mm-hmm.
because it's relative. It's relative to the other word. So when you
Mm-hmm.
compare a model to another different model, the model is consistent to itself, as in a word here is always similar to the word there, etc. But when you compare to each other, it makes no sense anymore because the
Yeah.
activation could be different. Just the
Uh-huh.
relative within the model
Yes,
makes sense.
yes, yes. And let's make it clear for anybody out there who knows like a canine and a dog are related, a canine and a dog, but they use totally different letters in the alphabet. Canine and Dog. There's none of the same letters in those words, and yet they are related. So the math of things, there's no intelligence to know that that is related. There has to be this context that is given. And so I want to show a visual of what we're talking about for 2 moments here on my screen.
So
This is InfraNotice. This is an application that I started using back at the beginning of MIT in 2023 to show off that knowledge graph. And so it lets you have a visual conversation with ChatGPT. And you can see all these words and as they are related. Okay, here I'm moving the word data around. You can see how it relates to things like paper, agent, evaluation.
mm-hmm.
And that's how that conversation went. But you know as well as I do, Andre, that a different conversation would cause different relationships.
Mm-hmm.
And if you go in here and say, well, in some cases, we're talking about futures or gaps and challenges over here, you can see those words. But what if it actually meant a different type of future, like stock
Yeah.
futures, like different types of gaps, different, you know what I
Yeah.
mean? So those
Yeah,
words
of
would have
course.
different context. And so all of a sudden, what you're
For the
talking about,
law,
yeah,
yeah.
it's yeah, this is so
Yeah,
this is
yeah,
for
yeah,
the audience to
absolutely.
see the visual
But
in what is that word association there. So there you
for
go.
the law, yeah, absolutely. But
Hmm.
obviously, just to clarify that, for the law of large numbers, yeah,
Hmm.
if you go on to an infinite numbers of text, etc., then the probability start to two models
Uh-huh.
different that do this kind of calculation. Then at some point, the distance between two words in the two different models just could coincide to the same thing, and they will coincide. The only
Mhm.
difference is the activation of the neuron that create that could be completely different.
Yes, that's right. Two different people can invent the
But
same
the
thing and have
relative, the
different paths
relative,
to
the
get
relative
there.
will
Yeah.
stay the same. So it's kind of
Uh-huh.
absolute. Relative between the
Yes.
two words is kind of absolute in long term. I mean, low the large numbers, yeah.
Hmm.
But the neuron activation of that kind of thing that created that could be completely different by consistent with the nemesis, which means that a generalized explainable AI cannot be, because the
Hmm.
activation of the neuron will be always kind of relative to their own system, although the result is the same for the large or great
Hmm.
numbers, which means it's very difficult to generalize
Hmm.
explainable AI based on the activation of neurons.
Yes.
All I'm
Yes.
saying is, if
Uh-huh.
I activate 3, 4 neurons to say dog, it doesn't mean you're gonna activate the same neurons to say dog.
That's right. That's
Although,
right. Exactly. Yeah.
although we both say dogs,
That's it. Yes, exactly. Two different
it
paths
does.
to the same destination. Two different paths, same
That's correct.
destination.
All,
Right. Uh-huh.
but all the paths together in my brain are relatively consistent to each other. And
Yes.
you're all the paths in your brain, they are all
Uh-huh.
relative to each other.
Uh-huh.
The ground truth, the final word is the same for all, but they're completely different neuron
Right,
circuits.
right. You've
Therefore, you cannot generalize
Mhm.
explainable AI.
I love this. Okay, so let's make it like I'm going to say this here. When you, for everybody out there, is non-technical, it doesn't matter. If you get onto a chat session and you tell the AI, you are a carpentry shop specialist who's going to help me with a shop project. When you prep it like that, you give it this, what's it called? Inbound, you give it this instruction for what it's going to be. It activates different parts of its neural networks to do something. It literally primes it. Okay. So here's one. I have a shop specialist one. I say, hey, you're going to help me do shop work, like with woodworking. But then I go to another session and say, you're a therapist helping people with addictions. The word vice means two different things. You have a vice that holds something, and you have a vice that holds a person. You know what I mean? You
Mm-hmm.
have an addiction. So those two words are the exact same word, VICE. And it has the same amount of letters, but it weighs differently. The weights are different, the meanings, the context, even though those two separate systems are the same
Mm-hmm.
AI. that got prompted differently. Hey, you're a therapist and for drug addiction. Hey, you're a carpentry specialist for shop work. The word vice is shared, there. And this is the difference. This is just like communication with people and how we have our own ways of defining and how we accept those conventions and those standards, of things. And so, but man, it's gold what you're talking about here. These are the concerns and the differences to be accurate, to be critical, to help cater a system to be specialized and yet safe, get the most out of it, but also be very cautious. You probably, with your frameworks and things that you do for clients, I know that there's certain things I do and don't do sometimes. And one of them for certain applications is I don't like to put in too many stop words. You can really make an AI stop if you give it certain instructions at a level where it says, "Oh, I'm just going to stop altogether." You just said something, hateful or not respectful for whatever reason it is. It's not going to do certain things, but there's only a certain amount of false positives, that'll happen in some cases. But on the large, we kind of never know what we're going to get when we're testing these systems because all of a sudden what's perfect at all, what's really good and efficient with certain operations, all of a sudden starts to fall apart when it comes to maybe certain domain specific knowledge, and that is, a lot of focus right now is catering to that specialty. What can you
Specific
speak
knowledge,
to that?
that's correct. Look, okay, so I could say two things. So exactly right. So the trend of the moment, again, you can find things in the State of AI report, those of you who want to read it. So first, to make AI model more safe or kind of that, there is new emergent kind of industry or niche industry, I would say, that what you're going to do is creating a software system that is actually a filter between the user and the AI model. And you could see already like that. I mean, the reason why it is very difficult for a user to, not all the time, but it's more difficult today to do adversarial prompt of a LLM model, etc. It's not because it's actually because the model first there is a filter between you and the model. They will not let you. This filter solution is part of the new AI safety industry. So company that provide software and solution to make the model safe, including a software filter or solution that sit between the user and the model. So therefore, when you do a prompt, by definition, you shouldn't have even done that. They go before to the filter, not even reaching the model, and stop you there.
Yeah.
And therefore, that's why the model it looks safer. It's not because it's safer, it's because you don't even touch the model when you ask something that you shouldn't touch.
Yeah.
And that's the first thing. On the fact that the model can be, and they will be specialized specific data niche, 100%. We already touched it, right? So as we say for the mapping and the post-training kind of trend, absolutely. I believe there will be even more post-train specialized model this year that we see in the past. Specialized specific metrics. Again, we say math before, it could be reasoning or whatever else. Or coding for the matter. There are already just special on coding, but I think we are gonna create even more on that. Again, there will be some that will be proprietary as they are now. In fact, to the point that I truly believe that since this post-training trend is gonna take up even more, a data labeling, one of the most famous one is Scale AI, right? If you're not familiar with the term, So they did back in two years ago something even a deal with many companies, including OpenAI.
Yeah.
What it means is OpenAI to use to generate more data or help to train better the model or verify their model, etc. They use on the backbone company like data labeling company, basically mean company that have large pool of trainers, that's the way they call it, in which they suppose the model and they either prompt it or they curate a list. Reinforcement learning by human film is not directly through the model, by the way. It's a complicated solution that before you train the model and then you actually fine-tune the model and then you build a policy, what is called. But without going to the technicality, yes, there are actually all these data labeling companies have a pool of what they are called trainers, which basically create more data specialized in certain subject, what they think the model is not good at. And they take all this data and then they refine with reinforcement learning, which is actually a procedure, it's not directly. Therefore, that's why I think the data labeling company, this year they will produce a top 10 performance model. One of these data labeling companies will come out and build because they're already being used by OpenAI to train their own model. So the natural consequence, they go directly and do them themselves. I would not be surprised to see that. In fact, this is one of the predictions of the paper.
I love this because it's funny how we have these worlds of words and terms, because these trainers are just like athletic trainers, finding the weak spot in the athlete and helping them get stronger on that.
Basically, that's what they do. It's a large pool of people that keep using and prompting a specific knowledge. They teach the model something they're not good at. Basically.
And we do this with labeling, out there, everybody. I mean, you take random data and it doesn't know what it is, and it will do something and learn from it. But if you label it and say, this is known good data, here's some data that is unlabeled, and that's like the test set, you split your data, and then when you have all this known good data, it can comprehend and work with it and go, oh, okay. And then you give it some random data and it's like, oh, I can see how that might come together based on this known good data. It's just like training an employee. This is a really good book. When you bind this book, it's going to look like this. And if someone was creating a book,
it's a train.
Yes, training is training.
Specific.
Yes, exactly.
But yes, the key is specific to whatever subject it is.
Yeah, that's right.
It can be one subject. And they will get very good in the specific subject.
Does your company have on-premises compute, or are you using particular hardware, or are you using a cloud? So tell everybody out there, if they wanted to come to you and for any reasons involving what you do, what in terms of security and what you're able to do there, what are you using? Or can you talk about that, I should say?
Of course.
Yeah, okay.
First of all, we have vendor agnostic. The reason for that, as a consultancy, we interact. It's the same reason why we say before there is different integration and connection. It's difficult to do the same infrastructure. It's not ready for agentic AI. The reason is most of our clients, they use different technology stack. Yes, some of them is in common, right? Google Cloud or AWS, or the public use a lot of Azure, I would say, public organization. But that's the surface. Then on top of that, there are other mid solution. They use specific things, etc. They're all integrated together. As when they employ us, so our contract with them, it's a bit silly if we go there. No, you should change the infrastructure. No, they usually come and then we adapt to the infrastructure.
That's it. Yeah, that's it. Thank you. That's it.
It's a bit silly that it doesn't work that way. As a consultant, you adapt to whatever the landscape or stack the client uses. Obviously, if you have Microsoft, that's not the case. But
but if you were going to train. If you were going to help a local company there train, post training, okay, would you use their architecture to do that, or what they have, or would you use a private system that you have to actually do some of that off-site? Like that's kind of the question.
Yeah.
Tricky,
sure.
right?
Okay.
Very tricky.
Okay. Yeah. Depends on the industry. The answer is depends on the industry. The reason is depends on the regulation they need to be abiding.
That's key. Okay.
For example,
yes.
In finance, because this is one of the industry we're talking the most, they have high regulation by SVA, at least in UK, Financial Conduct Authority, and certain things. First of all, they cannot do anything outside the country for certain regulation, for certain type of data, etc. So every cloud, if you use the cloud, has to be in UK. Certain type of security issue. And then there is a pros and cons. Obviously, you need to have encryption or whatever, etc., or even more than that, a solution that take care of the data, etc., to the point that if you do a prospective analysis on, okay, how much will it cost to have a secure system on cloud? And how much will it cost to the hybrid on premise? And you do the calculation, depends on what you do, you will might find out that the hybrid solution may be cheaper than doing on the cloud or vice versa, depending on the depending on much communication and processing need to do to anonymization of the data and renaming again, because certain solution you do for the finance, what you do is for security reason, in the pre-processing stage, yeah, you anonymize everything. You do all the processing at the hybrid on the cloud. But when you come back to the result, you need to put the mapping and the name back because otherwise,
Yeah.
exactly. So the way you interact with the process of the layer depends on the specific problem or solution you need to have. But if you need to use GPU today, the most effective way is definitely using the cloud. So you cannot escape part of this procedure and using the cloud to do
Yeah,
GPU.
especially with data location too, and where something is regionally. If you're
And
just
that's complicated matters
yes, it
because you
is.
need
Oh man,
certain data you cannot
uh,
move from there, etc.
right.
Blah blah blah.
If you have if you're a Google, like for anybody out there in layman terms, if you have a cloud account with any one of these providers, you have a matter of availability in different regions, and you can host your database in like North America on the West Coast, but there are all these other regions around the United States, around the globe that would allow other high access, connectivity to that data all the way around. So if you had companies around the world, your data would be also populated, in all these different places. It would be quick. And so it can get complicated, but in a matter of just a simple, what I want to just say, a vertical situation where you're just dealing with one area, you still have these tricks where you have to say,
On
well,
top of that, depends a
adapt.
lot on the volume or large data you got. Obviously, if you have a few terabytes, not a problem. If you need to analyze petabyte of data, let's talk about that.
Yeah, yes, exactly.
On top of that, there is another. The reason why I'm saying that is in the report, by the way. It's a number that shocked even me. Let's see if we shock the public as well, or even you, Daniel. Let's see. So many on the data set. Obviously, there are different data centers. Like there are small data centers. There's numbers only for certain type of processing. Okay, get it. On the whole industry data centers. Okay. How many do you think there are in US?
Oh, at least four for Google Cloud Services, at least four centers, maybe. I don't know.
In general, okay.
Oh,
Is in
yeah.
the report, okay, there are 3,000 data center in US. I tell you, it's the first in the world. Guess who is coming second and how many they have? 3,000, and more than 3,000 are in US.
Oh man.
Who is the second and how many they have?
I don't know. I'm going to let you take this one.
All right, here we go. Less than 300. So the 3,000, the less than 300 is Germany. A third is China. Less than 300. They have 200, I think it's 290 in Germany and 260 in China. 260 compared to more than 3,000.
In the US, right? Exactly. So there's so
that
many
means
ports.
If you need to process huge amount of data, don't have much choice.
No, it's a very big bottleneck. It's a very tight squeeze when it comes to that locale and what they have available. So, wow, yeah. So you have the ability to really pivot into this situation with any company pretty well. You have a nice team of specialists over there. And what you guys have, let's see, I want to look one more time here and let's see here. So are you working in, when you say like the computer human interface end of things, are you finding that you're creating special systems for this that are not basically a lot of back-end function calling to accomplish this? Or how would you suggest human machine interface, is being built right now and what you're doing? What's the approach for that? Because it can be a little, hazy.
Yeah, of course. Okay, so first of all, just for the public, there are two type of brain computer interface. So this, one is called non-invasive, which basically means somehow some sort some sort of hat with
Yes.
sensors that
Mm-hmm.
touch your
Right.
skull or skin or hair, something like that. Yeah,
Mm-hmm.
that's or front end. This is not invasive. Obviously, there is all another level, all another stories
Mm-hmm.
for invasive. The most
Yeah,
famous one is neural. It's not the only one, by the way. If you look
that's
at it,
right.
there are a few
Right.
others. Somehow even more successful than neural link. If you see what I.
Yeah.
And this is invasive means basically they open up your skull and they install something within the brain. So
Mm-hmm.
now, all of this is to, first of all, why this industry exists. I think it's important to understand that. And then I coming back to the straight point. So this whole industry exists because of what's the bottleneck of communication today is, okay, you may have noticed that, first of all, when you talk, yeah, usually faster than you write. Yeah.
That's right.
And when you listen,
Mm-hmm.
yeah, usually faster than you read.
That's right. Yeah. Yes.
Therefore, if you
Mhm.
notice, most people on WhatsApp, including me,
Mm-hmm.
you can when they send you an audio message, you can speed it up because you listen fast.
Yes. Uh-huh. Right.
But you can't really well, you can speed as much as you get the test, but so
Yeah.
you are faster inputting information to you with
Mm-hmm.
your ear.
Mm-hmm.
But when you go out, your faster is through your mouth rather than your hands.
That's
But
right.
that say,
Yes.
I wrote a post, by the way, there is a AI newsletter. I wrote a post entirely about that.
Mm-hmm.
But that says few tokens per seconds anyway. I think it's 10 word per second when
Mm-hmm.
I thought it is the fastest output information you can put. Yeah.
Yes.
And you can
Yes.
receive whatever the amount is with few
Mm-hmm.
tokens. Now, if you want to go to another level of the faster communication you could have,
Mm-hmm.
imagine directly thinking with your brain. At first, there is another layer that probably is important to
Oh
say.
yeah.
So, but basically, when you think, another preamble on the preamble, nobody knows exactly what the brain does. Okay.
Mm-hmm.
Yes,
Yeah.
we all compare the brain to the neural network, the large language model, etc. But reality is not exactly there because nobody knows exactly how the brain works, just
Mm-hmm.
to say under that. But
That's
there
right.
is an historical reason why we do that. So basically, if you look at history, in the 1800s, they were comparing ourselves and the brain to the steam engine.
Oh yeah. Mm-hmm.
And in the 90s, we were comparing our brain to the computer, if you remember. If you're old enough.
Yes. Yes.
And
Yes.
today so basically you always compare to the most clever thing we've done.
Uh-huh. Yeah. Yeah.
And so far,
Mm-hmm.
but nobody knows exactly how it works. It's
That's it. Yeah.
not be fooled to that. That's
Uh-huh.
the first thing. Finish this preamble. So the main uh, objective of the industry of computer interfaces in general is to allow to communicate 10 or 100 times faster than you're doing now. Okay.
Mm-hmm.
Basically bypassing ear and voice and directly goes to brainwave speed. Brainwave
Yes.
speed is speed of light or close to speed of light.
Mm-hmm.
We are speaking of, I don't
Mhm.
know,
It's
you
electromagnetic
get it.
waves, yes, and no matter how,
Exactly. And
and no matter what the
this is
frequency, it still moves at that
it still
close to the
move
speed of light because it's a field. Yes.
a
Hmm.
thousand times faster than we are communicating. Them.
Oh
That's
yes.
the reason
Hmm.
for the industry. Okay.
Oh
On top of
yeah.
that, there are
Hmm.
other basically what he's doing. Nobody
There's.
knows exactly, but you have a thought.
Hmm.
This thought is then compressed into words,
Hmm.
and then that. So there is a compression, decompression. Then when something arrives, the words are decompressed into some thought, and
Uh-huh.
then
Re-encode. Uh-huh. Yeah.
nobody knows exactly how it works. Don't think
Hmm.
it's exactly how the neural network or artificial
Hmm.
intelligence works because
Right.
don't I don't well nobody knows. Let's put it that way. This
Yeah,
is the most
every
unknown.
every fruit on the tree is different. They're all apples. They may all be oranges, but every one is slightly different, and we all have a different path and
Yeah,
a journey that defines our internal weights and balances and
absolutely,
biases and thoughts. So
absolutely.
that's our
And
yes, our
this is
uniqueness.
a preamble, but I thought was
Hmm.
important to do it. What we do on that? Okay, first of all, we do non-invasive skull and cap and stuff like that, and we try different technologies. Okay,
Yes.
again, as a consultancy, we need to be on the top possible knowledge and leading edge technology related to AI. And we do that internally, experimenting, because we need to be at the leading edge. Yeah, we
Yes.
try different
Yes.
ad set, etc., and we
Uh-huh.
try to understand what's the best they could do today. Yeah,
Hmm.
if you buy
Right.
certain hardware, etc., which AI solution you can build on top of it, or you can integrate on top of
Hmm.
that.
Right.
That's
It's
why we're doing
extensible.
that.
Hmm.
Okay,
Right. So,
doing
yeah.
that so that whenever we can advise or build a solution for a client, we have a bit of experience ourselves already.
Hmm.
That's why we do that.
I
So
see.
this is our internal project. I can give you an
Uh-huh.
internal project we have done is like imagine a screen, a tester looking at screen,
Hmm.
two colors, randomly they see color red or
Hmm.
blue.
Okay.
With that, obviously they have the hat on, non-invasive hat on. All we're trying to do is recording his brain waves.
Hmm.
Can we infer which color is looking at?
Yeah.
I think we got around a little bit short of 70% accuracy on that.
Wow.
And
That's
that's
very.
using, this is key for us,
Mhm.
commercial, quote, easy buyable hardware.
I know what you're
We
talking
are a
about. Yes.
company. We are
Uh-huh.
a company. We need to, if something is in the lab, oh, in the
Yeah.
lab, they can reach way more than that, way more, 90,
Yeah.
90. But it's still a laughing. You cannot, a sport, you cannot use in a commercial
Hmm.
environment, blah, 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 blah. There are a lot of limitations. It's not, but there are a lot. So for us, it's important to understand today what's possible in a commercial situation, not in
Right.
a lab.
Uh-huh. Right. And we've been dealing with this kind of stuff for a while and a lot longer than people may realize. So let's go back to the I think 80s and 90s. I could be wrong about this, but Apache helicopters have an iris tracker that
Mhm.
uses infrared light that when you move your eyes and look, it actually moves the focal
So, okay.
point for what your targeting is. Now, I had a friend who had an analog camera. Okay, he was a bird photographer many years ago,
Uh-huh.
about 15 years
Yeah.
ago. And inside of that, it had the same technology. And when you were looking inside the viewfinder, whatever part of the
Eye
screen
tracker.
you looked at, it would track you. That's probably one of the most practical and easy to approach integrations of human to technology communication. Like other
Mhm.
things are passive, like, well, there's your heartbeat, there's your
Yeah.
pulse, and there's maybe a
Oh,
few other
another.
things, but the direct communication is something that we can measure. And we have, and to your point, to your power on this, there was recently a test done where they hooked someone up and they asked them a question about what they wanted to do, what their decision was, what their preference was. Their brain sent the signal to the meter with the answer before they actually came up with that answer, before
Sure,
they
of course.
could even get it out. And it was a matter of them. They had, we train ourselves to be a certain way and we set ourselves up to be a certain way so that our brains will know before we even conceptualize in some cases. I know exactly what I wanted to eat, which is rare for some, I know. But you see what I'm saying? There is this matter of physiological provability. We talk about, explainable AI. Let's look at the explainable side of consciousness to approach this, and see where you don't need this big expensive system to gauge impulse. You
Oh
may or
no,
may not need the best MRIs. You may just need a $130
I can
EEG system that
I
you wrap
can
around, just like what you were saying.
absolutely,
Yes,
absolutely. I can
that's
add
it.
two things on that. Very easy
Hmm.
to do with very easy buyable, even two. I think one is called is Music, even old, 2, 3 years old hardware things. They have
Uh-huh.
just two electrode here, two.
Yes. Uh-huh.
Commercial one. I'm talking everything I'm talking about is commercially doable relatively easily.
Yeah.
So basically, with this, we can easily more than 99% accuracy if someone is asleep or not. That's very easy to do today, or is
Hmm.
even about to fall asleep. Another thing is more difficult to do is related to bring up. They mistakenly, I don't. There is a university for publicity. I'm not gonna name them in university, but one
Hmm.
on top of the world, they doing that for publicity reason. I get it. For marketing
Yeah.
reason, I get it. But
Hmm.
it's technically not brain-computer interface. I'm gonna show you, explain to you what it is.
Hmm.
But it's marketed as such, but it's not. It's
Hmm.
basically a system that instead of having to be brain-computer interface, the electron needs to be here, right?
Yeah.
not here in the mandibula or in
Right.
this bone. They
Hmm.
had actually the lectured here, and they call it brain computer interface, which is technically not true.
Ah.
With that, they show with a couple of papers, which is true. It's just not BCI, it's not brain computer interface. They can read what the person was quote thinking. The way
Yes.
it works is as follows. When you think a certain word,
Hmm.
etc., out if I think certain word, but I don't move my mouth,
Hmm.
the problem is the activation of the muscle is already starting. So what they reveal when I think about dog and I don't move my mouth,
Hmm.
the activation is already there
Yeah.
before I. So they detect the activation of the muscle when you think the word. Therefore, they detect the word even if you don't say it.
Hmm.
But it's from the you see the muscle they are gonna
Yes.
about to move your mouth or
Uh-huh.
your mouth part of that.
These are a really important point you're making because that is really the rest. The whole body has a brain to it, in a sense, and muscle memory, and
Yeah.
the fact that there. I study a lot of neuroscience, and I'm completely captivated by the topic and where this bridges over into the realm of actual living creatures and where our communications really stem and how that translates. But you were learning, in doing this work, you're learning more about the human body as well. You're learning more
So
about actual, the physiological act of thinking and communicating and the impulse and how we predetermine a lot of our preference, by habit, by practice, and then we'll know what we want before we say it. Or before, the moment before we decide, our body will have a decision in some cases. Hey, and some of that's episodic memory. Some of that is, kind of circles back to the AI where, hey, is it really intelligent? Is it really considering? Where is that logic? This is all a profound amount of direction, to take research. And we've all, thought about all these things from movies and science fiction for the years that we've been around to see it, and so have many generations. But now more than ever, some of these things become practical, where it makes sense to have emergency communication in a situation. You might be doing a rescue. You need to be able to not maybe you're underwater.
mhm,
Maybe it's a dive operation. Maybe you're doing
mhm.
something where it really be helpful to send particular impulses as signals and indicators to people. But there are all the supporting systems around this too. So, like you say, and I want to back it up, which is when it comes to training and when it comes to models, like it's never just this one thing. It's going to be a few things in parallel working together to formulate that compliance, that
Mhm.
safety, the real directive that's being given, seen through to its end, to its delivery. All of this is measurable, but the way it's happening and the way we're going about it is it's like the Wild West. There's so many things to discover with this. Even last week, I was learning to use technology for neuroscience imaging systems, and it was completely approachable for anybody to get into. And I thought to myself, wow, things have changed. And the fact that we have computers is one thing, and all the applications and things on our phones to learn and discover and grow and build with. But there are so many things that we're coming to understand that everybody has this potential to discover something right now if they really put their work into it and do their due diligence and really
Mhm.
study and really do those experiments as purely as possible, as best as we can be balanced and unbiased. But so it's such an exciting thing, and especially to hear from you, because not only have you been around different systems of possibility and you have helped shepherd these standards, and I know that I briefly discussed some of the things that you did when I was advertising this, which was your contributions to certain I think it was analysis standards. I forget exactly what tools that you were using as like a C++ type of
Mm,
bridge. There was something, but over time you've put a lot of work into a lot of science. That is my point
mm,
though, and that
okay.
you're not just like your company is exceptional because you're not just helping, data integrations, okay, and all these different types of project deployments. You're really trailblazing some of this uh, you know, expanse in front of us right now with what you're doing because as many people as I talk to and work with, I get to hear you say things I haven't heard anyone say yet about very important factors in all of this measuring. And it's just a phenomenal conversation to have with you as one person. And you just know so
Thank
much
you.
about this. So we only have a few minutes left. And I wanted to know if there was anything else you'd like to share with the audience before we go. And I definitely want to say, hey, this is AI Technologies in London, and you can look them up. It's aitechnologies.co, so .co,
All right.
and take a look at them. And you don't have to necessarily be in the UK to contact Andre and his team. In fact, you could be anywhere. You could be on the space station. He doesn't care. He'll take
Yeah.
your call
On
anyway. So
Mars.
yeah.
Yeah. You're already on Mars. Give it a
Yeah.
shot. It will take a
Mhm.
while, but
Yeah,
have
we'll get it.
fun.
We'll get the signal. It'll take a minute.
Uh,
Well, look, it's been a real pleasure, and it makes me feel good to know that I have a solid person and company that I could refer people to for some of these efforts and some of these needs, because it's hard to find people doing it right and being very, maybe there's a lot and they don't talk about it, sure, but you're very critical in the right areas, and your participation in the ISO standards say a lot about your approach and really gives me a lot of confidence to work with you on different projects. And I hope it
Thank
would
you.
lend I want to extend that same confidence to anybody else who would approach this, because there's a lot to think about. And if you find the right people to do that sorting for you and to give you those reports, hey, Dr. Andrea Isoni is one of those people. And so,
Thank you.
reach out to him. So again, thank you so much for taking the
Thank
time
you.
with us today, man. It's been an incredible conversation. A real delight to just hear what you have to say and to learn from it. And so, thank you so much for your time. And I look forward to following up with you and keeping up with what you're doing in the coming weeks here as well as things unfold. Very exciting times. So again, everybody, this is Dr. Andre Isoni. I'm Dan Wilson with the AI Think Tank podcast. Thank you so much for taking the time to listen. We look forward to seeing everyone again. You all have a wonderful day out there and take care. Have a happy Saturday. And we'll be seeing you again soon. Thank you so much, Doctor. You take care.
Thank
We'll
you.
talk to you
Thank
very
you. Thank you,
soon.
Daniel.
All
Thank
right.
you.
Have a good
Bye.
one. Bye.